Hi guys, so let's do one more example with completing the square. This time we're going to solve an actual problem where we have the quadratic equaling 0. If you're not familiar with what that solution is, this is a quadratic, which means it's a parabola, so it has that U shape. And when you say I got a quadratic equaling 0, what you're actually asking for is, this thing is on some coordinate system, and you can imagine something along these lines where you're looking for the x coordinates of the points where the parabola intersects the x-axis. That's what we're solving here. If you try doing that, um, let's say directly by factoring, like you try to just say, okay, break this up into two factors, x, well, I guess we got a 5 there, right? So it'd be like a 5x plus something times x minus something. You'll find that you're not going to be able to do it, not with these particular coefficients. These are not nice coefficients. Those answers we're going to get, the solutions, they're not going to be nice numbers. I know that. You might not know that. I just know that because I set up the problem, so I know that the solutions aren't nice. But anyways, let's actually solve this using completing the square. So as we saw in the last video, we have to deal with that 5. We have a coefficient on the x squared that's not a 1. We need it to be a 1. We're going to have to factor out the 5. So we rewrite this as 5 outside parentheses x squared minus, now remember when you factor out a number, what the result is, what gets left behind in the parentheses is every term is divided by that number. So we have to do negative 4 over 5 here, x minus 7 over 5. Then we're going to complete the square on the parentheses. However, there is something slightly nice about this example that wasn't true for the previous example. The previous example, this was like y equals, and we had to keep the 5. But when you're trying to solve for the roots where this thing has a 0 on the other side, that number doesn't actually matter. The reason why is because we could do a bit of algebra, divide by 5 on both sides, and if you have 0 divided by anything, it's still 0. So this is kind of nice. We don't have to worry about the 5 and then redistribute it at the end. In other words, this is equivalent to solving this problem. X squared over 4 fifths x minus 7 fifths equals now 0. You could have left the 5 there. You could have distributed it back in at the end. You would have ended up getting rid of it anyways at the end. We just cut to the chase here and got rid of it right away. Okay, now we're ready to complete the square. We look for our cross term. We find its coefficient. We have to divide it by 2 and then square it to get our quote-unquote special term. Okay, so we need to do negative 4 fifths. And we need to divide it by 2. And then we need to square that answer. And you may or may not remember how to do this. I'll remind you how to do compound fractions or fractions divided by fractions. So here we have a fraction. We're dividing it by another fraction. You might say, what are you talking about? 2 is not a fraction. Every number, whole number, is a fraction if you put it over 1, which you can do. It's always over 1. The trick here, in parentheses here, is you keep the top number, so negative 4 fifths. You change the division into multiplication. You flip the denominator, and that becomes, in this case, 1 over 2. Then you solve the fraction and you square it. Here, we're going to have negative 4 times 1 gives you negative 4. And 5 times 2 is 10. Or what am I doing? Hold on. Wait a second. I told you in the last video, cross cancel if you can. We can cross cancel here. Divide negative 4 by 2, you get negative 2. Divide 2 by 2, you get a 1. Okay, so we avoid making big numbers by just having cross canceling and basically having a reduced fraction. So we got negative 2 fifths here. That ends up being squared. Okay, to square this, we just simply square negative 2, which is 4, square 5, which is 25. There is our special term. Let's take this guy real quick. Okay, what you're going to see next, there's a little bit of a, call it a preference for how you do this. When you have y equals the quadratic, I showed you to add in the special term and then take it away on one side of the equation. You can always do that. You could do that here. It's really up to you if you want to do that or if you want to do this. So I could add 4 over 25 here and then take it away. Or I could also add 4 over 25 to the right-hand side. Now, that might seem confusing, like why are there 2 different ways of doing it? In reality, there aren't 2 different ways of doing it. This is, you could think of it as, had I had, the minus 4 over 25 on this side, and then I simply did a bit of algebra and added it to the other side, I would have got that. I just chose, because I know that we're looking for an answer here where we're going to get x isolated to one side, I chose, instead of subtracting from this side, to simply add it to the other side because it's going to end up happening anyways. Okay, so next we've got this completed square. In fact, that's why we call it completing the square. Why is this called the completed square? Because you could write it as a perfect square. Now, you can say this is x, and then remember we got to figure out it's going to be plus or minus a number squared. That is your completed square. Without that 4/25, it's incomplete. You just kind of have this part here, and that negative 7/5 is not going to help you complete the square. That's why we had to do it ourselves by adding in the right term to make that happen. Okay, what goes here? You have to remember that the number that goes here is what you get when you take your coefficient of your cross term and divide by 2. Now, I don't want to write negative 4/5 over 2. That's not simplified. I want to go down to where we got the simplified answer there. It's negative 2/5. So we want to throw in our negative 2/5 here. I mentioned this in the first video. If you really wanted to check, you could actually FOIL that out to confirm that it is in fact equal to this. Okay, so that's that. Now we have a minus 7/5 here that we could have here, but you know what? I'm going to take care of that now too by saying, you know what? In the previous step, let's imagine we added that to both sides. Okay, so on this line here, and you know what? This is getting a little too crunched. Let me move this down just a hair. So now we've got this is equal to, well, the right-hand side, we have a 4/25. 4/25, well, it's plus 0, but right, that's just 4/25 plus 7/5. All right, we need to combine this, and in order to do so, we need common denominators. Here's a nice trick. You might know the trick to get common denominators is multiply your 2 denominators. You should do that when the 2 denominators are, well, I should say when one of them is not a multiple of the other, or one of them is not a factor of the other. But in this case, 5 is a factor of 25, or you could look at it the other way. 25 is a multiple of 5. So rather than multiplying them together and getting a big number in the bottom, which would be 125, then you're going to have to reduce at the end. Actually, all you really need to do is make this fraction bigger, scale it up so much that this turns into a 25. How do we do it? Well, if you multiply 5 by 5, you are going to get 25, giving you a common denominator. You can't just go multiplying denominators willy-nilly like that. This is algebra. You have to make things equal line by line. The way to keep things equal, if we want to multiply the denominator by 5, is to also multiply the numerator by 5. This is allowed because this fraction, the overall fraction we're multiplying by, is just a 1 if you look at it. Of course, we don't want to simplify it to 1. That would be unproductive. What we want to do is scale everything up now. So this is going to be, let's look at the right-hand side real quick. 4 plus 7 times 5 is 35 over 25, and we have 25 here. So we had a common denominator of 25. And then, of course, on the left-hand side, we still have this x minus 2/5 being squared. Okay, I'm out of room here, so I have to move up to some clear real estate. All right. Of course, we need to simplify this fraction here. So this 4 plus 35 is just 39 over 25. And we actually want to solve for x. We want to get x isolated. How do we do that? Well, actually, what we're going to do, I'll do it in this previous step, is we're going to take the square root of both sides. By taking the square root of something squared, you effectively get rid of the square. I need to do it to the right-hand side too. And you know what? A little short on room. Let's move this over just a 10. You have to remember, you cannot just simply take the positive square root on the right-hand side, because this entire quantity in here may or may not be negative. You don't know because you don't know what x is. So when you take the root on the right-hand side, you actually take the plus and the minus root. You consider both possibilities. Over here, or down here on the next line, we have plus or minus the square root of all of this, 39 over 25. Because we took the square root of this, this is now just x minus 2/5. Since we got rid of the square, we can also get rid of the parentheses. They're not needed. We're nearly there. We want to isolate x, so we just want to bring the 2/5 over to the other side of the equal sign. So we add it here. We have x equals two answers. So we're going to have 2/5 plus that result and minus. We can condense it. We can write it all at once by writing plus minus here. But keep in mind that there are two solutions here. Okay, you may or may not remember how to do this. I'm going to go over this briefly. When you have a fraction, like let's just write sum a over b. B can't be 0 here, but it could be anything else. When you have a over b all under square root, that is equivalent to just saying the square root of a up top over the square root of b on bottom. That is a root property that you need to remember if you don't have it memorized already. So 39, not a perfect square. We're going to have to just go ahead and leave it as root 39. I said at the beginning of this video, you're not going to have a nice solution. That's partly why, because root 39 is an irrational number, but it is what it is. And then this is going to be over the square root of 25. But we don't have to write a square root of 25 if we can actually simplify it down. The square root of 25 has a nice answer. It's 5. You might also recognize that we have common denominators. We have 5 on both of these. So I also mentioned that this is actually two solutions in one. If you want to see what the two different solutions are, they're this. So one of your solutions is x is equal to 2 plus, or let's do the minus first, minus root 39 over 5. And then you have x is equal to 2 plus root 39 all over 5. These are the x coordinates of where the parabola graphed by the original quadratic equation would intersect the x-axis. That's what we just solved for. We used completing the square to do it. The other option we would have had is to use the quadratic formula, sometimes called the quadratic equation. This is just one way to do it. Okay, I hope you found that helpful. Thanks for watching. See you next time.